Because I'm going to go a little rogue and teach this slightly different than the book does, so you best be on your game. It also might be different than Miss Kennan in that I'm going a little beyond and I expect a little different work. So, be clear and understand. Okay, you will need a certain pre-calculus skill to succeed in today's calculus. So let's review that pre-calculus skill here. If I told you that sine of alpha is negative 3/4 and that alpha is in the third quadrant, I wanted you to find, I'm not sure what this is. Would you scratch that? I don't know what the heck I'm doing. Find cosine of alpha, because it's not negative 3/4, I assure you. Okay? Question is find cosine of alpha. This is a non-calculator problem. Oh, you gave this to me. Oh, gotcha. Okay. Now, if you were with a calculator, you'd be tempted to hit the inverse sine and figure out the angle and cha-cha-cha, right? It's not necessary. In fact, it's more what you use a calculator. If you know what you're doing, this should be pretty easy. Sine. Way back to Algebra 2, you learned sine is the ratio in a right triangle of opposite to hypotenuse, the old SOHCAHTOA. Okay? Now, if I wanted to draw a picture of this triangle, I need to draw a triangle in the third quadrant, and the opposite is -3, and the hypotenuse is 4. Now, as far as that negative is always attached to the opposite adjacent. Hypotenuse is different. We don't do that. Okay? So I'm going to stick that -3 onto the y side, which makes sense. It's going down, so negative y is logical. Are you with me? Now the question is, what's the cosine? The cosine would involve the adjacent and the hypotenuse. I don't have the adjacent side, so I would need to find it via Pythagorean theorem. What's the adjacent side? Is it 5? 3, 4, 5, right? Yeah. That's ridiculous. 5 cannot be a shorter side of the triangle. So please don't think 3 and 4 mean 5. That's only if 3 and 4 are the legs. Then 5 is the hypotenuse. Yes. That is not the case. In this case, the adjacent side is square root of 7. Is that, double square root of 7. Is that positive or negative? Negative. Why is it negative? It's left of the axis or in the third quadrant. Either way, the x is negative. So now let's talk cosine. Cosine is adjacent, -√7 over hypotenuse 4. Boom. Okay? Now we used a triangle and given information to draw a picture. Would you use that same approach to that one? No calculator. Right? I didn't specify what quadrant, but it's kind of implied. Inverse cosine has to be first or second quadrant, right? So your triangle, because its cosine is negative, it must be drawn in the second quadrant. Your triangle should look something like this. Now you can find the tangent of such an angle. Your answer? -√24 or -2√6. Right? Okay. The cosine implies a triangle. You need to find the missing side to do the tangent. The missing side by Pythagorean theorem is root 24. Then you do the tangent opposite to adjacent. We cool? Okay, now let's see how this might come into play in calculus. If I asked you to take the derivative of y equals arc cosine of x implicit, you might say, well, man, I don't know what to do because I don't know the antiderivative of arc cosine. I don't think you do anyway. Do you know the derivative of cosine? How could you make it a cosine? Rewrite as cosine. Okay, now that's what I mean by implicit. Isn't this the same as cosine of y equals x? That's an implicit equation. Y is implied now, not explicitly clearly stated, solved for. Now it's an implied y. Now I can take the derivative with respect to x. Implicit differentiation stat. What's the derivative of the left side with respect to x? Negative sine y dy dx. And what's the derivative of the right side? 1. Beautiful. Okay? Now I'm going to solve for dy dx. Dy dx is negative 1 over sine y, yeah? Okay? Now it feels like you're done, and you're not. The derivative needs to be put back in terms of x. Instead of sine of y. You cannot leave your answer that way. Savvy. So the question now is, sine of y, what is it equal to in x terms? Well, use this original statement to make a triangle. If I draw a right triangle, y, is it an angle or a side? It's an angle. Okay, you take the cosine of an angle, right? So I'm going to call this angle y. What is cosine the ratio? Cos adjacent over hypotenuse. So in this triangle, adjacent is here, and the hypotenuse, I guess, is 1, right? Now that implies then, by Pythagorean theorem, that the opposite side is the square root of 1 minus x squared, eh? Now, what is the sine of y then? Opposite to hypotenuse, so Katoa. Square root of 1 minus x squared over 1. So then, if I bring that back here, then at the end, my derivative in x terms is negative 1 over square root of 1 minus x squared. Why is what? If I need to work with this, I need to make it a ratio. So if it's x, then it's got to be over something, and the only thing it can be is going to. Okay? You bet. Okay. Now, this is going to be a little sloppy. Okay, messy. But that said, the principle is still the same. I'm going to first rewrite. Rewrite it implicitly. That's the same as secant y equals 3x squared. The implicit derivative. Take the derivative of both sides with respect to x. What is the derivative of secant y? Secant y tangent y times the derivative of the inside, dy dx. What's the derivative of the right side? 6x. Cool. Okay? Now what do I do? Solve for dy dx. Isolate dy dx. I'm going too fast? Thank you. I need that feedback. Okay? So if I solve for dy dx, I need to divide that stuff away. 6x over secant y tangent y. Now you can leave it like that, or you could say, you know what, secant in the denominator is the same as cosine in the numerator. That might help. I'm not sure if that'll help, but let's go there. That's 6x cosine y tangent y, yeah? That's the hard part, the not so intuitive part, the part that you have to do through instruction, and that's the derivative is supposed, the original problem was written in x terms. So it's kind of assumed that you're going to give your derivative in x terms. This is not in x terms, it's in x and y. So you need to find a way to replace those y things with x. That's done by trying to put in terms of x, draw the triangle. The triangle comes from the first step in your work. That's what implies what the triangle looks like. Y is the angle. And so the sides, I'll call that 3x squared over 1. What are the sides? 3x squared. What is that? Opposite hypotenuse, adjacent. If secant is adjacent to if cosine is adjacent to hypotenuse, what's secant? Hypotenuse to adjacent, right? So that is probably, not probably, it is hypotenuse, and that's the adjacent. You follow? So if the hypotenuse is 3x squared, and the adjacent is 1, then you're always going to be using the Pythagorean theorem to find our missing side. By Pythagorean theorem, that opposite side is 9x to the 4th minus 1. Correct? You with me? Okay. Now I'm ready to replace these guys based on this triangle. Y dx is 6x is fine. What's the cosine of y? You know, it just occurred to me that I'm really dumb. Why was it kind of counterproductive to replace the secant y with cosine y? Didn't I know what secant y was the whole time? Yeah, so maybe I should have left that as cosine. You see what I'm saying? In retrospect, I think I made a foolish mistake replacing that secant with numerator cosine because I knew what secant was. So why do that? It feels easier to leave it where it was. Okay, so that was a mistake. Tangent. The picture definitely is necessary for tangent. What's tangent? Square root of 9x to the 4th minus 1 over 1. So that's a non-issue. All right. That's pretty ugly. That's about as ugly as you'll see. I have these out of order. You try, please. Would you take the derivative of arc sine of x? You might start by writing it as y equals arc sine of x so it can be rearranged. These are the two big ones. Do these two, work with your method, amigos, and then we'll move on. How'd you do? Yes. So if this is a sine, Now do the next one, which is the other section. There really are two you're going to have to straight up memorize. Arcsine and arctangent. The others you're going to do by showing this process every time in my class. What are we doing? Take your ratio, then square. How are we doing? All right. Sorry, I'm rushing you. I don't want to rush the process, but we do have other stuff to cover. Did you get 1 over x squared plus 1 for arctangent? Yes. Now, in terms of what I prefer you have 2 of these memorized and the other 4 you show the process on. Arctangent, I want you to know, actually, let's call this arctangent of u, rather. The arctangent, the derivative of arctangent is u squared plus 1 in the denominator. Okay? The derivative of arcsine is also one you need to know. It's 1 over the square root of 1 minus u squared. Tangent is the one that's positive and no square root. Sine is the one that's negative and has a square root. Eventually we'll get those into our brain. I would hate to have for you to do this every time on some problems. All right, now the way I prefer this is if I give you, if the question is the derivative of any of the other 4, arc cosine, arc cotangent, arc secant, or arc cosecant, and you show the process I just talked about, like we did there. Implicit differentiation, triangle back substitution. Are you with me? But if I give you arctangent and arcsine, then recall. All right? Now, let me give you a little practice then how you could use recall with chain rule. Imagine, is this the right thing in your notes here? Okay. All right, so imagine if I gave you something ugly, like f of x is 3 arcsine of e to the x, and I wanted the derivative. Now, because it's arcsine, you're not going to show all that process. I don't require that you do all the triangle stuff, okay? Instead, you're going to use the fact that the basic, if f is arcsine of some function, then the derivative is 1 over 1 minus u squared, right? But because I have a function within a function, I'll also have to do a little bit of chain rule action. So let's do the derivative on the outside. What's the derivative of arcsine? First of all, what happens with the 3? Can I just leave it out front? Okay. Times the derivative of arcsine is 1 over square root of 1 minus whatever's inside squared. So in this case, e to the x quantity squared. But then, by chain rule, I have to take the derivative of the inside, so times e to the x. So in arcsine, I expect you to just know the derivative and use chain rule or product rule and stuff as necessary. Try this one, please. Should your derivative here be a number or a function? A number. You're actually asking for the slope at 1, so it should be a numerical value. You're going to show the derivative first and say, I will evaluate this at 1. Then you'll evaluate it at 1. Ready? What's your answer? I'm feeling 18 fifths, yeah? Hey, if I take the derivative of arctangent, it's the 3 comes along for the ride. The derivative of the arctangent is blank squared plus 1. In this case, blank squared is 2x cubed squared plus 1. But via chain rule, derivative of the inside is then 6x. I need to evaluate that at x equal 1. That's 3 over 2 squared plus 1 times 6, which is, oh, okay, 18. Yep. Okay. Now, this is one of the great gotchas of Calculus 1. This is a really weird, to me, if you think about it, it's a really weird outcome. You're taking the derivative of a trig function, and yet in the answer, no trig. It's all algebraic. That's pretty cool. Now that goes to the fact that tangent is a side ratio. You're giving a side ratio, so the derivative should be a side ratio. Now, what I'm getting at here is that a problem like this is very misleading. Because you look at that, and you think, I mean, who's going to think trig there? There's not a whiff of trig in it, right? And yet, the answer is trig. You've got to have those two memorized, because otherwise, when you get an integral like this, your mind isn't going to think trig. You need to recognize this as saying, oh, that's the derivative of arctangent. If I see fraction with 1 plus something squared in the denominator, that's a derivative that came from an arctangent derivative. You follow? So this then, you'd say, okay, that's just a 2 out front of arctangent's derivative. It's 2 arctangent of. That derivative must have come from taking the derivative of arctangent. Right? All right. So this guy, take the antiderivative. What does that kind of look like? Arc sine. The -5 comes along. -5 arc sine of x. This time I also have to evaluate it. Requires a little bit of trig skill on your part. What is the arc sine of a half? Which asks, at what angle is sine 1/2? 5 or 6. Okay? Minus arc sine of -√3/2, which asks at what angle and in the appropriate quadrant is sine -√3/2. -π/3. Now that's minus -π/3. So it actually ends up as plus π/3. So we're looking at -5 times π/6 plus π/3, which is -5 times π/6 plus 2 π/6. -5 times 3 π/6 is -5 times 3 times π/2. I think we'll agree. So -5 pi over pi. All right. So what's the derivative of arc sine of x? 1 over the square root of what's x squared? What's the derivative of arctangent? All right. You need to get those memorized. Anything else you need to show the process on. So if I ask you to take the derivative of y equals the arc secant of x, what would you do? Show the process. You rewrite it as secant of y equals x, take the derivative implicitly, solve for y, dy dx, and you got a triangle, right? Okay. Do you have questions on set 63? No? Oh, good. Put it in. 63. There's the AP question. Do you want to, I can't remember if I put the AP question answers on that sheet or not. No? Isn't there an AP problem at the end of 63? Okay. Number 1 also, did you say? 1 and 10. And 3. And 5. Okay. Okie dokie. 14. Hey. Okay. 14. This is calculator okay, so if you just know how to use your calculator, it should have gone well. But number 1 should be periodic, but weird periodic. Do you have something? Oops, my bad. Violating your privacy. Still violating privacy. Okay. Do you have a graph that looks something like that? It has 3 peaks within the given domain. Now, you got a calculator. You shouldn't have missed that. You said, oh, this looks hard. You can't even put a graph in your calculator. You're really a sissy. Okay? All right. So, I haven't seen, this was a 2002 question, so I haven't seen anything that involved just graphing in a graphing calculator for 12 years at least. So this is pretty rare. You don't usually get a point for being able to use a graphing calculator. That said, take it where you can get it. Did you do okay? That was just 1 point. Did you graph it correctly? Okay. B. During what intervals is the particle moving to the left? What does moving to the left have to do with velocity? Velocity is negative. So you need to know left implies v negative. Graphically, that means find where the v graph is below the x-axis. And that then, hopefully, you got, now, they said calculator, so I wouldn't be surprised if you have decimals. But do you have something like pi to 2 pi, or 3.141 to 2.5, or 6.282? Yeah? Then 3 pi to 4 pi, so something like 9.42 to 12.56. And then from 5 pi to 16. That was 2 points, one for each missing interval, 3 points actually. 2 points were for the answers, 1 point was for for the reasoning. Particles moving left when velocity is negative. You had to justify why you looked where you did. Okay? Which is basically what Karis just told us. All right. C, find the total distance. Doggone it, I think I wrote you a note over here, yeah? Did I write you a note?
Yeah.
Okay, good. Distance. This is a huge idea that we have to cover a lot, but distance is the idea of, I don't want to talk about, is he moving right or is he moving left? I just want to know how far did he go, period. Okay? Now, if you want to know how far you went and not talk about direction, then you need to remove direction. If you remove direction from velocity, you remove its sign. And if you remove its sign, you have to use absolute value. So if they want distance, it involves integrating the absolute value of v. What do you call the absolute value of velocity? What do you call how fast you go without respect to sign?
Speed.
Speed. When you integrate speed, you get distance. When you integrate velocity, you get displacement. This then is what you do. Use your calculator to evaluate that, and you should have something like 10.542. Okay? 1 point is for the integral, basically is 2 points for the answer. It's not how we grade it anymore. All right, so never mind that. D, is there any time at which the particle returns to the origin? Ouch, that's a difficult one. So this would be the part that separates the good from the great. If you can get this one, then you're great. All right? How would you find if it's at the origin? What did you get into? You want to know when it's what's zero? Position, velocity, acceleration, time.
Acceleration.
You still haven't got it yet. Keep saying stuff.
Speed.
You know?
Position.
Position, yay! If it's at the origin, then its position is 0. So you want to know if there's ever a case where x equals 0, right? Now, I don't know what its position is. It would have to do with the velocity, yeah? Okay? They tell you that the particle starts at the origin. So at time 0, it's at the origin, and up to some time, t, let's call this, all right? You follow? Actually, let's go here. Let's start here. Do you agree that if I want position, I need to integrate velocity, yeah?
Yes.
All right. This would be the position at some time minus the initial position, yeah? All right. The position initially is the origin. They say it starts at the origin. So that really means the position at any time is just equal to the area under the curve, yeah? From 0 up to a certain point. You tracking? All right. Now, if the area under a curve is going to be 0, then it either has to be one of two things. From 0 to 0, which is dumb because we know it's at the origin of 0, or some positive negative area action. Look at the graph. Are you ever going to get a case where the negative area cancels out the positive area and they're perfectly equal and you're right back to 0? Unfortunately not. There is no case, there's nowhere to get positive area canceling out negative area so that the displacement is nothing. And so our answer should be no. It is not possible. It never returns to the origin. As far as how do you say it, you would say 0t is always positive. Parenthetically, you could say the negative area never cancels the positive area. Never enough to cancel out positive area. And so we conclude then that the particle is never going to be returning to the origin.
Good morning, Kevin Jaguars. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Girls basketball team for high school students fill all of our varsity basketball teams. You'll get a cool warm-up, free food, and travel to magical places like we reach. Come to the girls basketball players, or Coach Olson, D.P. Olson, Jessica Duck, please remember you may only check out Chrome and the past period before 7 hours. Please return Chrome immediately after 7 hours. If you have an overdue item, you're unable to check out a Chromebook, and always remember, Chromebooks are back with you. Interested in traveling to Mexico this summer? Well, to learn how to eat tacos and go to the beach? Tell your parents to join us for a parent interest meeting tonight at 6 p.m. in Mississippi. Please check the lost and found field from lobby to see if you have items there. Anything not claimed will be donated for. NJHS will meet 7th hour tomorrow in the auditorium. Junior high art. Zero word sculpture is on display in the library, which you please take us home for the spring. Be sure to check out James, Taryn, or the Porter so they know your sculpture is going home with the rakers. Girls mentoring workers will have their annual cookie celebration tomorrow during 7th hour.
The question correctly?
Mentors, please bring
We need, the hard part by far is the geometry.
sprinkles and decorations. Remember to wear your tie-dye t-shirt. That Blue Jack, the student athletes among first ever are as follows. Cassidy Simpson.
Ooh.
Moving up from JV one season to varsity, the next is always a big step for any athlete. Being asked to start on varsity for the 7th place team in the state is a huge leap.
Okay, so that's what we're looking at, right?
Time to be in that position. We can combine the on-court stuff with our
With me?
off-court stuff. School leader, positive attitude, professional.
Let's go here. This is a problem that's building off a problem we did the other day. So, wouldn't you agree that if I want to get this in terms of H only, then I need to figure out what's a BH relationship, yeah? Alright, if this is equilateral, then the water triangle is also equilateral. So that means that I could focus on this triangle, yeah? How could you solve that for height or base in terms of height, or replace base? Does right triangle trigger a reference triangle, yeah? Let's do the reference triangle, shall we? Stay with me? Okay, so you'd say b over 2 is to 1 is to height is to root 3, right? So base is 2 height over root 3. So the area is 2 height over root 3 times height over 2. So at the end of the day, area of the base is this ugly height squared over root 3. Yeah. You follow? Therefore, you could say something like this. The volume is height squared times 4 over root 3. Now you can do the calculus. dV dt is cha-cha-cha. That's not nice.
I feel like we're being.
You should. Start a fight. AB versus BC. All right. And you're good on there? Solve for DHDT? Yeah? Okay. 10. Question on 10. 10 still question. Okay, here we go. What the heck is all this? 10 is. Okay, you should split this. Actually, you should. Never mind. Simplify this. Chuck. Darn it. Can we turn this in? I will put these on the key online. This is due today.
Yesterday, I
Make sure I get 63. I'm going to do this. I'm gonna do it.
No, I'm gonna do it. I can start it next week. Yeah.
I will find it. I'll figure it out.
Other people have. First of all, I gotta give myself.
And I have to sell Santa Claus. I'm doing work for Triumph.
I went 481.
I didn't know you were a musician.
Not.
Very musical artist society.
I just make
That's a musician.
Yeah, well, second one.
Oh, okay. He's got eventually she's got a wheelie back. That's what you get your speed.
But still, it does have weight because you're like gravity says.
Yeah, but
Because
once you
the
get it rolling, then you're.
Fractions and all that stuff.
Yes, yeah. What's up, home diggity?
I just think about a fun thing to do for my passion for my final Spanish presentation.
Your passion? Spanish. Spanish is your passion.
I was gonna do something really fun because everyone's doing like sports and stuff.
Why don't you do like
Food Network.
ship and go in?
Yeah,
go
exactly.
in.
HGTV.
Yeah, let's why don't you do a little demonstration of how to make something on tiki?
I was thinking maybe the Food Network or HGTV.
Yeah, you should do something foodie. You make lots of good foods. Yeah. See?
We have a test tomorrow.
Yes and no.
And the PTA.
Yes and yes.
Hey, Mr. Rickman.
Hi.
I was wondering if I could actually take the test tomorrow because I haven't had a chance to prepare.
All right, it's fine with me as long as it's going. Is it a test or a quiz?
Or quiz.
Okay. All right. I got that quiz ready. It's any time you want.
We have a test
What time tomorrow?
And no.
Why no?
Either third hour or actually
Test
either
13.
third hour or
No,
how long
quiz
after school
PTA.
is that? Probably not.
Let's see. Tomorrow I have to help my wife put in the library, so probably till about 3:15.
Okay, so probably during third hour.
Okay, sounds good. Julio. Oh, I forgot to stop my recording. Cool.